Ooh, there is nothing quite like getting home, is there? After a long trip. I just went to Toronto to give a talk for Tailscale. Hang on, something's missing here. There we go, that's better. And that's what today's video is going to be. It's a talk talking about why port forwarding is dangerous and how to access your home lab remotely using Tailscale. So those of you that have been using Tailscale for more than 3 years, congratulations. Tailscale was only founded in 2019, right here in Toronto. This is a Toronto company. Now, obviously my accent will tell you I'm from England originally. I live in Raleigh, North Carolina these days. But Tailscale is a fully remote company. Like everybody that you see here, like no fixed abode in terms of work. The irony, of course, is that Tailscale is a connectivity solution. I don't know, I just think there's a beautiful poetry to that. All right, so a little bit about me. Some of you know me, which is great, I guess, but I'm assuming a lot of you don't. This is my cute floofball of a dog called Archie, named after my favorite Linux distro, by the way. If you want to find me, there's a bunch of stuff where I'm on the internet. You'll probably be sick of me by the end of this anyway, so happy days. I saw an F1 shirt in the back. Yes? Who's your racer? Brad. Moving on. That movie was pretty good, by the way. Yeah. All right. So let's talk about home lab. Who's got a home lab? Everybody. Yeah. See. And Dee mentioned this in her talk. Actually, there comes this point where every home labber transitions from it being a home lab into being home prod, and then you've got to have a home prod and a home lab. That's what we're going to talk about today. So, a home lab, it's a place where you can educate yourself, learn stuff, break some eggs, make mistakes, create a firewall rule that locks you out of SSH on the node that you need to get to, right? That's the point of a home lab. A lot of people conflate that with home prod, which is Jellyfin or Plex, you know? The number of times in the morning I've woken up and Home Assistant's been down or Jellyfin's been down and I can't play my 5-year-old Her Peppa Pig. Woe betide you if you get in the way of that pathway. The other thing it can do is it can give old hardware new life, particularly in 2026. Who's seen RAM prices lately? It's just unbelievable. So I bought 96 gigs of DDR5 RAM a year ago for $200. That same stuff is worth $1,200 US dollars. So I don't know how many of your Canadian space bucks that is now, but it's a lot. It's also a place to discover how important digital sovereignty is. Right? We've seen it time and time and time again where big tech, one of the big, because the world's ruled by like 5 companies, right? We all know this. Doesn't matter what vertical you pick, there's always just like Nestle, Coca-Cola, Apple, Google, like you get the idea. With self-hosting, we have this amazing opportunity to be completely in control of our own destiny. We're building a small private internet just for us and our friends and our family. You get what I'm saying? Like, digital sovereignty is so important. Own your data. Now, you might think that self-hosting requires a basement full of a 19-inch gigantic Dinosaurus rack. Not anymore. You can do a lot with a little these days. Like, this little computer is about this big. And you can run every self-hosting app you want on one of these, because they don't take much juice, except for maybe transcoding media, maybe doing local AI, but if you're doing that stuff, I think you're already a little way down the path. If you just want to back up your photos or have a self-hosted RSS feed or something like that, that's all you need. They're $150 on eBay. Go buy one, experiment, have fun. They're power efficient, they're small, and you don't need a gigantic rack in the basement. Now, this was my very first home lab machine. Look at this beauty. Isn't this gorgeous? This is from like 2009, 10 maybe. It's a 5070 Ti inside. I wrote this down. It's an LGA 1366 socket with an i5 950. Back when Intel had triple channel RAM. Just marvel at the color scheme. I thought that was cool back in the day. It didn't run any special software. It just ran Windows. Now, this hard drive here, that one, is the reason that I'm stood in front of you in this room tonight, because that 1.5 terabyte hard drive had all of my TV shows and movies on it. Turned my computer off one night, woke up the next morning, gone. spindle locked on the drive. It was a Seagate firmware bug, and I'd lost all of that data. And I was like, ooh, well, that sucks. What can I do about this? So I started going down this rabbit hole of RAID with a Drobo and Synology, and then eventually, Unraid came into my life. We actually have an Unraid employee at the back of the room. Hi, Adam. So Unraid was the first step really in my Linux and open. Well, it's not all open source. It's got a closed core. It's a bit like Tailscale, really. There's a little bit at the middle that's closed, but it was the first step in my self-hosting journey. You can see I've got a ton of different drives, and the reason this was so important was because at the time I was a poor student. I can't drop £2,000 as it was back then on an entire server of perfectly matched drives and spin up an artisanal ZFS array. Oh no, I have to take the drives that I can afford at the time, which I think one of them is a 320 gigabyte drive on this page, just to give you an idea. Like, it's not easy, this stuff, or it certainly didn't used to be. And I just think like where we're at now with the technology being where we're at with things like Tailscale and Unraid and all these technologies making it easier for people to get started, there's never been a better time than now. Now, I promise you, self-hosting, despite all the warnings, is a ton of fun because you own your data, right? We talked about how important that is, right? But you can also lose that data, and it's your fault. Isn't that great? If you're not paying for the product, you've heard this moniker before. If you're not paying for the product, you are the product. Well, sometimes, even if you are paying for the product, you're also the product. And sometimes when you're paying for the product doesn't work properly, and it still loses your data. So the only way to guarantee it, really, is for you to have a little bit of craft and care and build a solution carefully over time and own your data. I talked about how important that is, and build a solution piece by piece. That's things like offsite backups replicated across Tailscale, of course. You know, for example, I just went to see a friend of mine at the back of the room and left a computer at his house. That's now my offsite backup from Raleigh over Tailscale to Canada. It's geographically distributed, like different countries. And then I've got a box at my old server, actually from England before I emigrated, is my cross-continental backup, you know? So I am more resilient than GitHub these days. Now, my favorite self-hosting apps. Proxmox, it's a given. Who knows what Proxmox is? Most people. You know what VMware is? Right? Proxmox is that, but not crap. Well, it's not got a business model that's going to eat your lunch. It's free and open source software, which you can choose to pay for, which is the important thing. 4J, who knows what that is? Yeah, who knows what Git is? GOGS? No? Well, they're all the same project. GOGS forked into Git and Git forked into 4J. Such is the nature of open source. It's essentially a local GitHub. It supports things like GitHub Actions. Who's heard of GitLab? It's an alternative to GitLab. I should have just led with that. You can do things like GitHub Actions locally. It supports the same syntax, so you can literally drop in the same files you've already been writing. And this speaks to another element of home labbing that I adore, is I can mess around with this stuff at home, like I did with Tailscale, honestly, and go to my boss, hey, these guys are cool. They know what they're doing. We should be using these guys, not those guys. Screw OpenVPN, you know what I mean? And so the same thing with 4J and GitHub Enterprise and that kind of stuff. Like, it's just, there's no contest to free and open source software because there's not going to be Copilot injected in there for absolutely no good reason, as far as I can tell. Yeah. It's not that I hate AI. It's a complicated thing, right? And I don't want you to get the wrong impression here, but there's a time and a place for it. And shoving it down my throat every time I try and make a commit or open the GitHub app is not it. Anyway, sorry. So the soapbox is up here. I'm not even standing on it. Jellyfin. Who knows Jellyfin? Who knows Plex? Boo, last week. Boo, Plex. Yes. Yeah, those that don't know, Plex raised their lifetime pass to $750 last week. That's $750 to stream the files that are on your hard drive in your basement, using your electricity, using your hardware, using your internet connection, and you bring the files as well? Come on. That's a bit much. LibreSpeed. Who knows LibreSpeed? Okay. Who knows speedtest.net? Everybody, right? LibreSpeed is that running in your network. So if you want to do something, you know, like iPerf, where you can check the connection speed between two different nodes, I use this in the browser. It's way easier. You don't have to have the client and the server listening. And LibreSpeed is pretty great. Home Assistant. Yeah, MVP. The idea, I mean, back in the day, we used to have the Philips Hue app, and the thermostat had an app, and the garage door had an app, and you get the idea, right? Home Assistant talks to all those different things and brings it together into a single surface. Home Assistant as well have done something, they've founded the Open Home Foundation, and they are being incredible custodians of the free and open source ethos and spirit of the movement. If you've not heard of it, not checked it out, go check out the Open Home Foundation. Even if you're not interested in home automation, just go and have a look. Because they're doing projects like SendSpin, which let you open source copy things like Sonos, where you can have multiple speakers throughout your house using open source software, all play in sync. It's amazing. No business model. Now, my 5-year-old at home had a hand in this slide. Who can guess which bit she picked? Yeah, it's the pink bit. Yeah, she's 5 and she's a girl. Now, we have all of these services running in our home lab. How do we access them remotely? Well, in order to understand where we are, I want to take a little step back and sort of think about the internet and where it came from to understand how we got to where we are. So this is a computer. We've all seen this picture before, right? This is actually in Norwich Town Hall. And a fun fact about that is that's where I got my master's degree in computer science. It's literally around the corner from my university, so I have a soft spot for this place. And this was a computer. Well, in fact, this was one bank of a computer. This wasn't even the whole thing. Just look at the truck. I mean, it's basically prehistoric. And in the beginning, these computers were disconnected giant hunks of machinery that were disconnected and occupied entire rooms. Eventually, these computers lived on small trusted networks, maybe within inside the building, so that you could talk to one room, could talk to the next room. But over time, people started getting used to the idea that maybe these different rooms might want to talk to rooms in other buildings. So they started building simple point-to-point connections where these machines could call each other. We all remember the movie Hackers, where the guy puts the thing on the thing and it dials the dial-up modem and yeah, good. I never know these days. Like, my kid asked me, we went to a thrift store and we bought a DVD and she looked at it like, what? What's this? I've never felt so odd in my life. But these things could call each other via modems, right? It's like a digital fax machine type situation. But they were one-to-one in nature, right? You wanted to talk, like Berkeley wanted to talk to New York, for example, or Harvard or something. They would call each other directly. There was no TCP/IP, really. It was just a direct connection. Over time, that matured and TCP/IP became a thing, right? And these networks grew in complexity. And so did the ubiquity of the availability of computing at the same time. We're talking the sort of era where Jobs and Wozniak are in their garage building the Apple II and the Lisa and all that kind of stuff, right? This is a sort of 70s, 80s period where all this stuff is very nascent and very cutting edge and beginning to really metastasize in front of our eyes, right? So after a while, the internet starts to look at, well, it's obviously a lot more dense than this, but it starts to look a bit like highways, right? Across like interstate network, across the country. Infrastructure is coming. These small interconnected networks are now what we call the internet. Right, I've probably not told anybody anything new, but the reason this is important is because to get from there to just having the internet, you've got to put guardrails around this stuff. Harvard can't just have their computer sat out on the public internet for every person to just talk to. That would be crazy. And so the term firewall comes along, and this actually has a basis in the real world. You know, you've heard of fire breaks in a stud wall, a firewall. It's designed to stop fires. It's designed to stop the ingress of certain things between other things. Firewall. When computer networking and security systems began developing in the late 80s and early 90s, the engineers borrowed that term firewall from the real world. And then, of course, we started to transcend continents and become, you know, the AOL CD that we all got. Well, at least I got when I was a kid. I don't know. I don't judge. So the solution to all of this, of course, was IPv6. Yeah, it's like IPv6 is, I think I'm going to go on record at this point and say it's a bit of a failure. Like, does anybody here actually use IPv6 in anger? Yeah, engineers don't count. Normal people, okay.
IPv6 address from my ISP. So.
Okay, exactly. Like, you can't guarantee you get an IPv6 from your ISP. And the reason that this was all required was because we were running out of IPv4 addresses. You know, the 192.168.0.1. Like, that's an IPv4. It's got 4 octets to it. The solution wasn't IPv6. That was fancy. It wasn't IPv6, it was network address translation. Now, who's heard of NAT before? Okay, good. The idea here is you've got one device on a private network that presents to the outside world as one device. But you can use one public IP to represent many private. It's that one-to-many relationship. And that's because IPv4 addresses are limited. And so if we have dozens of these services running behind a firewall, network address translation is required. So what's the solution? How do we connect to stuff behind a firewall where we know that there are 100 private services or servers running behind the firewall? How do we get there? Well, port forwarding, of course. That's the obvious solution, right? Yeah. Because you just opened up your home lab or your production environment to the world. And you remember how we talked about how Harvard didn't want to do that? Well, why do you want to do it either? It doesn't make sense. Port forwarding is dangerous. And I learned this the hard way. 17-year-old Alex, you've got to imagine slimmer, younger, less hairy me, left Windows Remote Desktop open to the public internet on port 3389 with the password of 22. The laughter is deserved. Yep. I got owned pretty quick. So the general idea here is that port forwarding, you would take an IP address and a port pairing, and you would put into your firewall a rule that says, allow traffic to pass when the rule set is matched for an incoming packet. And you can kind of think about an IP address like an apartment building and the port number a bit like the apartment inside that building. It's like, where is the service, and then where is the service inside that building? There's a few common ports, like we're all familiar with SSH on port 22, DNS on 53, HTTP on port 80, I assume. Some others, of course, exist. But the solution isn't to go full Gandalf mode either and close the ports and close the firewall and say nothing shall pass, because then, well, you can only access your stuff when you're at home, and that's no good either. Because it means that if you have no open ports, nobody else can get in, which is good, but neither can you. So just to visualize it one more time, right? So I'm sat here in Toronto, and I want SSH to a server back in Raleigh where I live. No ports are open in my firewall. I can't get in. Well, that's good, because no one else can get in. So I open a port, and now I can get in. But now my firewall resembles Swiss cheese, and everybody else can get in as well. And that's not what I want either. We've done this slide, Alex. Oh well. It's always a good talk we can get Morpheus involved too. So the alternative, of course, is to install real VNC on your gateway PC, forward a port on your Linksys router running OpenWRT, I guess, and call it a day. No, of course. The actual solution is Tailscale. The personal plan is completely free. A couple of months ago, we updated our pricing. 6 seats for free, unlimited personal devices. I don't know of anybody else doing anything quite as generous as that. So you can all use your home labs to your heart's content. It's completely free, and we've committed to make that free plan free forever. Hooray! Tailscale lets you connect to devices across the public internet without opening any ports on your firewall. Now let's talk a little bit about how that works. We're going to solve the NAT traversal challenge, and I'm going to try and explain this, but it's a very dense topic, so please, if you have questions, we've got a panel in a minute. Save your questions for the panel, and we'll do our best to answer them. But this slide is the whole problem in one picture. You want to connect to a service running behind a residential firewall, as we've discussed. Now, imagine if the firewall was a receptionist, and imagine if someone inside the network starts a conversation, so they're speaking outbound. The replies are allowed back in through that same route. But you're not just going to let any other conversation in, only conversations you've already started. That's kind of how a stateful firewall works. That rule is usually good, and it's why your laptop can browse the internet, but other people can't reach stuff that's inside your network. Now, step one isn't to punch a hole, it's to announce and find out what each device looks like from the public internet. And to do that, we use something called a stun server. So Tailscale the client on your device will announce to a stun server, hey, Alex's phone is currently on this T-Mobile connection and is announcing that his public IP is this. The outbound connection has a port of, I don't know, 1, 2, 3, 4, 5 attached to it. If you talk back on that port right now, he'll let you in for the next second. So once we've announced that to stun, which is a free service we offer to all Tailscale users. It's just a core part of the Tailscale product. We have to have that happen on both sides of the exchange. So if you've ever done a Tailscale ping and it takes 3 or 4 pings for it to establish that direct connection, that's what's happening. Stun is coordinating those two ends of the connection and then making that direct connection from point A to point B without opening any ports in your firewall. It's just using the stateful firewall state kind of against it. We're kind of abusing a technology that isn't designed to work that way, but it's perfectly fine that it does. And so when that happens, both peers send those UDP packets at the same time, and now they can talk directly to each other. And that is the magic that you've experienced with Tailscale. When you install it, we do a bunch of magic with WireGuard keys under the hood, and then you're connecting 2 devices together. All of that just happened in the background in a couple of seconds. And that is the magic of Tailscale. And before you know it, you have a mesh network of devices. It usually means when you get a direct connection, you get better latency. There's no hub and spoke model like the central. Do you remember when we all started working from home in 2020 that everyone's VPN gateways just crumbled under the load? If everybody had been using Tailscale back then, everything was talking directly to everything else. That wouldn't have been a problem. There is, by the way, that was an incredibly compressed version of this absolute gem of a blog post that was written by Dave Anderson. So if you've got any lingering queries, which I'm sure you do because I probably butchered that, take a look at this blog post. I guarantee you'll learn a couple of things. But from a home lab perspective, there is no easier way to connect to your stuff remotely than Tailscale, at least not that I know of. So if you want to find out more about Tailscale, and you want to see more of my face for some reason, YouTube. I'm on YouTube everywhere. And I'm supported by an incredible cast of Tailscale characters that make incredible software. So I'm just the tip of a very, very talented iceberg. Everybody else beneath me does all the hard work, and I just get to sit atop and take the credit, I guess. All right. I think, oh yeah. Yeah, that's how I felt the first time I installed Tailscale. Right. I think it's probably time for questions with a Q&A panel and... Hello, engineers. Yeah.